Hello everyone, my name is Alessandro Pilotti, I'm CEO at Cloudbase Solutions. I'm going to talk a little bit about Ceph on Windows today. How many of you guys are already using it? By any chance? Nobody? Yeah. Good. All right, so why porting Ceph on Windows? So Ceph is, of course, the most popular distributed open source storage solution, so it's kind of a no-brainer on that side. And Windows Server, on the other side, has a very large market share, especially in the enterprise. So if you want to bring Ceph into that world, you need, of course, to deal with Windows as well. Traditionally, this has been done with the Ceph iSCSI gateway, which has a few problems, including the fact that it's not exactly brilliant in terms of performance. So one of the primary goals here, as I will anticipate soon, was about improving performance for this type of scenarios. How did it happen? So it happened to a partnership between SUSE and Cloudbase Solutions. So we worked fantastically together. This happened a couple of years ago. And they sponsored our work. They were extremely supportive and everything. And we managed to bring this all this work into the open source domain, of course. Architectural goals. So we wanted to have the user experience on Windows to be as close to the Linux one as possible, meaning to have also nearly the same command line experience, making sure basically that if somebody was a Linux administrator, used to work on Ceph on Linux, in the moment in which they had to work on the Windows side, they could simply just reuse the same identical type of knowledge they had in terms of even finger memory, to say so, in running commands and everything, RBD commands and so on. At the same time, we wanted it to make sure that it integrated as well as possible into the Windows ecosystem, so running as a Windows service, and if somebody came from a Windows administration background, they could also feel at home in using the service, like not feeling it's something like that comes from a completely different world, just put on top of the Windows operating system. In terms of performance, we wanted, of course, to outperform the iSCSI gateway and get as close as possible to the Linux native performance. I will briefly talk about this later, but we definitely outperformed our goals here. We wanted to be secure, right? And recently, this is some recent work that we did. We wanted also to add support for Windows clustering, which is very important in the Windows world when it comes to high availability and fault tolerance. So Windows Server for lower cluster, cluster shared volumes, and scale out file server. Okay. In terms of supported Windows versions, pretty much all the relevant Windows Server versions, meaning 2016, 29, and 22. And for development purposes, also Windows 10 and 11. So you can also install it on your laptop or VM and whatnot and try it out. One of the non-goals was to port OSD to Windows. So you still need, of course, a cluster running on top of Linux, right? So we are not aiming, at least for the time being, for having a completely, entirely Windows native solution. In terms of architecture, as I mentioned just now, we have the OSDs running on Linux. And on Windows, we have a user space process called RBD WinBD. Which contains then the librd, librados libraries, and also a DLL called WinBD, which talks to a driver. So this is a kernel driver that we developed called the winbd.sys, which handles, of course, all the disks. So we ported librd and librados and all the relevant Ceph CLI to Windows. RBD mappings are managed by the RBD WinBD, as I just mentioned. So, and again, those are wrapped also to RBD commands like RBD device map, unmap, device list, and everything. So these are all things that should be very familiar to anybody working with Ceph. The mappings are also managed at boot, meaning that whenever you reboot the system, there is a service that will automatically remap everything that was defined as a persistent mapping, right? So you don't have to take care of that. RBD and many CLI tools work like on Linux, as I just mentioned. WinBD. So the big part of the work was actually writing from scratch a kernel driver that could, of course, mimic the functionalities that you are used to find on Linux, exposing, of course, volumes to the Windows operating system. In technical terms, this is a virtual store port mini port driver. implements basically two communications options. One, the one we started with, was the traditional MBD with TCP/IP, also useful not only for originally not useful only for Ceph, but also for anything that might use MBD. And subsequently, we replaced it with a local user space kernel channel, which is much faster, right? So we avoid basically running TCP/IP commands between user space and kernel, and we have a dedicated channel that helps us performing as fast as we can in communicating between these two layers. License-wise is LGPL 2.1, and you can find it on github.com Cloudbase WinBD. There is also a fork on github.com Ceph WinBD. All this work, of course, while, as I mentioned before, is done by us, by Cloudbase, it's also strictly integrated with the Ceph community. So, for example, all the upstream work that we're doing in the libraries and everything, it's all work that we do as part of the community. Configuration file, so we wanted also the administration experience to be as similar as possible from this perspective. So the default location, which on Linux will be etc Ceph, ends up on the program data Ceph directory. Those are Windows traditional best practices, right? So instead of doing just like C etc Ceph, we prefer to follow the standard practices on Windows. The normal procedure will be like, if you have already a cluster running, you just copy over the Ceph.conf file and the keyring from a Linux node. You change paths as needed, and you have a working environment. So it's very, very easy. I will show you in a bit through them. CephFS was a secondary goal we had as well. The main issue there on the Windows side is that Windows lacks a native Fuse or similar user space file system driver. There are open source solutions. The most popular one is, one of the most popular ones is Docani, that we will leverage here. So basically, it's a package that needs to be installed before we can have it as well. Before we can have CephFS on Windows. I will show you a demo, but as I use this example, you just run ceph-docker.exe and -l, and then the drive name you want to have mapped, and it just works. It's an evolution of the previous Ceph dock and work that already existed in the community. Being Windows, as you know, package management in Windows is typically done with MSIs, traditionally. So we have an MSI that we created, also open source, that helps basically installing everything at once. So it's extremely easy, can be automated, can be integrated in any deployment strategy, like, for example, Ansible and whatnot. There are continuous builds available, and also there are releases for Pacific, Quincy, and soon we're also going to add a Reef one. You can find them on cloudbase.it Ceph for Windows. Now, talking about virtual machines, the hypervisor that comes with Windows is Hyper-V. So we wanted to have also seamless integration with Hyper-V as well, meaning being able to boot volumes directly off a mounted mapped Ceph image, or being able to anyway attach disks coming from there. So we did that as well. I will show it in a demo. Here are some simple PowerShell commands that allow you to do that. Performance. Performance was a key topic in the work that we did. It's a huge improvement over the iSCSI gateway. So this was the primary goal. As I mentioned, we achieved it and we outperformed it significantly. Not only that, but we managed also to outperform RBD, NBD, and KRBD on Linux in our test. All the tests are open source, documented in our blogs. So if somebody wants to replicate what we did, they're there. The reason for this is that the WinBD protocol has been implemented with device IO control, which again is the way in which we can communicate between user space and kernel. And we improved a lot all the IO concurrency in that space. This is how we achieved the performance that we had. Here's also a link on the slide in case you would like to look how it works. As I mentioned before, we do all this work as part of the community, and that means that is an ongoing work. Traditionally, it's not the first time that we as a company work in large open source projects, bringing them on top of Windows. We did it before with OpenStack. We are doing this still nowadays with Kubernetes. We did it with on the SDN side. Okay, so it's a traditional issue, the fact that people tend to say, okay, great, we have Windows support, but then most of the developers come from a Linux background, and we end up having a lot of regressions due to specific Linux code and might not be portable on Windows and so on. So testing is extremely important in any of these type of endeavors, right? So not only we work with the upstream community, but we also work with the testing infrastructure to make sure that we have CI testing, so continuous infrastructure testing on continuous integration testing on Librados, librBD, libcephs, and we have also a bunch of additional Windows-specific tests, right, which are only there. All the jobs are running upstream against every PR. So whenever there is a PR coming in, we run those tests. They are extremely helpful in avoiding regressions, because any developer can say, oh, this breaks on Windows, let me fix that, or let me speak with the Windows developers and find a solution. It helps a lot. On Windows, if you want to release a driver, you have three ways to do that. The first one is only for development use cases in which you don't sign the driver, which means that you have to tell Windows at every boot, hey, I want to use this only for developer purposes. The second one, which is the one which is available right now, is to have it signed by a specific entity, Cloudbase in this case. So all the drivers that we release are built by our automated infrastructure, signed and released. So you can just install them and they just work as it is. And the third option is to get them also certified by Microsoft. This is a so-called WCL program. We delayed a little bit this work for the simple reason that we wanted originally the Linux Foundation, the Ceph Foundation, to sign it. But to do this type of work, you need to have a specific entity to do that, and this was not possible. So together with the community, we agreed to do it ourselves as Cloudbase. So expect very soon also a Microsoft certified driver available, okay? Of course, the certification process takes a little bit more time, right? So we will still keep continuous builds and stable builds for all the releases that we do, which are signed by us, and then periodically we will also release the one signed by Microsoft, okay, since it takes significantly more time to do that. What changes? I mean, what is the advantage to have the Microsoft signed one versus the Cloudbase signed one? In most use cases, nothing. One of the use cases which is very important is that this allows also to have a secure boot. So if your servers are booting with secure boot, then you also need to have every driver, so everything which runs in the kernel has to be signed by Microsoft for obvious security reasons. Okay. There are other, of course, advantages, but let's say this is the main one. Now, in the past months, we worked on a feature which was not a primary goal initially, but it's something that got asked a lot around, and it's something very common inside of the Windows world, because everything which is high availability and failover, let's say in the Windows world, typically requires to have a failover clustering solution, okay, which is part of the Windows server, and various solutions can plug in into this architecture. One of the advantages, for example, you have cluster shared volumes. So you have, for example, one RBD image mounted on multiple servers and visible within all those servers. So whenever you create a file in one of them, is automatically visible on the others, okay? And it can also be exposed externally, for example, with a scale-out file server. So this is extremely useful and very important in enterprise scenarios. It's currently available already, marked as experimental. Requires a few features like persistent SCSI reservations and a few other things that need to merge actually upstream in Ceph, so in the user space side, right? There is work going on. I put a link here on the tracker, on the Ceph tracker. So if you want to follow that, we release already builds which already include these features, and I will show you some of them, one of them actually in one of the demos in a few minutes. So this is the next extremely important at this point use case that we want to target, and for the rest there are a bunch of minor maintenance, bug fixes, and other things that we still do as the ongoing work within the community. Right, demo time. Okay, so here is a Windows Server machine. I already installed here, just to save a little bit of time, Ceph, okay? But I'm running the installer just to show you how it works, okay? So you just download it from our website, ceph.msi. You can either follow the typically next type of experience or automate it with MSI exec within whatever automation workflow you might have, Ansible and whatnot. So as I mentioned, it's installed, so we'll just show you the basic UI. You have two main options, the Ceph CLI and also the Windows Ceph RBD driver. You could, maybe in a development environment like your laptop, you might want to install only the CLI, so you don't have to install forcefully all the time also the driver, but on any typical type of server environment, you will just select both of them, or leave the default in this case, and just press next, and that's it. So normally I will press next and then change or just install, and that's it. So we don't need to do it because it's already installed. Good. Oh. So now, as you can see, I have only one image mapped, which is Hyper-V 1. Okay, I will create a new one, and here in parallel I have an SSH session which is on directly on one of the Linux nodes with the OSD running. So as you can see, I can see the same identical things. In terms of configuration, I have, as you can see, a keyring, and I have a ceph.conf. And if you look at the configuration, it's very familiar, right? I change a few things, like for example, the paths are different, but the rest is identical to what you used to on Linux side. Good. Next, we are going to create a volume. So the command is identical. I'm running it on Windows, but I could have run the same identical thing on Linux. I'm just switching between one and the other just to show you that this is the same thing. So now you can see there is a Win1 volume mapped there. Then we can map it. So it's mapped. And then we can do a device list. And as you can see, we can see that the mapping is there. Good. If I do a get disk, I will see both disks included. Now, if you come from the Windows world, you might be familiar to this particular UI. So as you can see that a new volume showed up with 10 gigabytes. I mark it as online. Initialize. New volume, NTFS, map to NI. That's it. And here's my volume. So I can create files, folders, and whatnot. Here you can see the E and C. Okay. Simple as that. Good. Unmapping is as simple as that. voila, as you can see, it disappeared from our list, okay? The image is still there, so if I map it again, I will find, of course, my same data and so on. Good. So this is the first demo. Next, I'm going to show you the Ceph side. So as you can see, we don't have a volume at the moment. I'm going to create one. Here it is. Now, starting fuse, and then we can just write a file inside of this volume just to have something that I will show you also on the Windows side. Okay, so if I look at MNT, okay, now we have a simple file called hello from Linux. Now let's switch on the Windows side. And I'm going to map the same volume on Windows. So here you see there is a new volume called X. I could have called it whatever, right? But as you saw in the command line, X is the name. And here is our hello from Linux. Let's create also a new file here. Hello from Windows. And as you can see, I can see also the other file there. So this is extremely useful in case you want to have, of course, a file system which is shared between both Windows and Linux. And the content can also be easily retrieved in the same way. Simple, right? Good. Well, a mapping in this case is just about killing the process. Eventually, we'll have also service that will handle the mappings for you. Good. Next, I'm going to show you Hyper-V. I already created an image for you, which is, probably you saw it already before. If I do an RBDLS, there is already a Hyper-V one, okay? So this is an OpenSUSE VM, okay? It's just quickly converted, so I could use it, of course, QMMG to convert it, but it's going to take a couple of minutes. So we prefer to save that during the demo so you don't have to wait for it. It's already there. What we need to do is to simply create a VM at this point. Well, we have to map it first locally. Then we create a new VM. And we map it. The only thing I have to change the mapping number. Just a moment. Okay, it went automatically online since the previous one was online. For Hyper-V, you have to put it offline so that it can be used. Okay, so now it's mapped. Well, I can show you the rest from the UI. So the machine is off. I can start it and start connect also the console You see group loading and everything, okay? So all the data, all the I/O is actually happening from Ceph. So there is no local I/O from the VM perspective. This is also very useful, let's say, in case you want to unify the storage location for your virtual machines across multiple solutions, let's say KVM, Hyper-V, and so on. Good. Okay, I have one more demo for you. We can leave this running right now, so it's not important. But as you can see, it's coming up, and you have everything. For the cluster, I will switch to a separate demo environment because we need 2 servers. So this is a separate cluster dedicated for this, which also includes the Ceph Windows components built with integrated cluster support that I mentioned before. So get disk shows at the moment we have only 1 disk on both sides. So there are 2 machines, okay, identical in the same cluster. Also, I can do a get disk here. See, 0. Now, let's take a look at it. So as you can see, if I do an RBDLS, we have an image already, which is this CSV1 that we need to map. The command for mapping is identical. Note the extra option for enable PR, so persistent reservation, because it's an experimental feature, so it's not already baked in by default, okay? So if you want to use it right now, you have to specify that extra option. Same command on both sides, because this is the important part. We need to map the same identical image on both machines, or if the cluster will be made by more than 2 servers, so on each one of those. Good. Now, if we do a get disk, you will see we have the disk mounted here and here, the second one here, okay? Now, what we can do, we do the failover cluster manager, add disk, so the disk shows up. It's online. Add the CSV. And that's pretty much it. So if I go on the cluster storage, I will see my volume 1. Even here, if I just create a text file, and I go on the other side, it's there, right? So this is extremely useful if you want to integrate Ceph into the Windows world in a high availability context. Good. Taking it offline is more or less the same. Sorry. So removing it from the cluster first. And then we just remove it entirely, okay? Another interesting thing is just we can also validate, the cluster. Cluster validation is something that is typically performed on Windows cluster to make sure that the whole environment is cluster ready, you know, networking, storage, and everything. In our case, we want to test only the storage side of things, but I wanted to show you how all the tests are performed, because not all the type of storage is enabled for cluster, right? Because it might not support all the, for example, SCSI features which are needed for having the persistent mapping across persistent reservations and being able basically to map a device on multiple nodes. So if you run it, as you can see, it's doing all its work. So if you're familiar with this UI, it's something that it's very nice to see when it comes out all green. All right, this was our last demo. I can leave it running here, and we have still a few minutes for questions, if you have any. Over there.
Hello.
Hello.
We currently use a Linux Ceph cluster as our backend.
Yeah.
We use Ceph.
Mm-hmm.
We're currently using an SMB gateway
Okay.
to actually write data from our Windows clients to
Okay.
the Ceph cluster.
Mm-hmm.
I noticed that when you actually did the mapping of the Ceph, you didn't specify any user authentication. Is there any possibility of doing that, or linking it with like an LDAP server to actually then do?
Well, it's so all the authentication is handled by Windows itself in this case. Like it will handle any other external device. So user rights and everything are strictly related to that. And of course, there is a need to have a better integration with Windows One. In terms also of file permissions, as you probably saw, the Windows file already took by default, for example, an executable flag, right? Which is what happens typically, also what you will do on when you try to map, I don't know, NFS or something similar.
Okay, so
Yeah.
in actually like for mapping the UIDs.
Correct, yeah.
So, okay, I
Yeah.
was just wondering if there
Yeah.
was
Yeah, more integration work needs to be done in the TAR as well, correct, yes. Yeah. Any other question?
Yeah.
Yeah.
So regarding the performance, right? Like
Yes.
how much of benefit we are seeing compared to iSCSI
Mhm.
with respect to scale?
Yes.
So what is the scale that we can grow compared to iSCSI? We have 256 like limit on the iSCSI side, right? Last.
Correct, yeah.
So any improvement on the
Yeah, so the question is about the question is about iSCSI performance and scalability. One of the main advantages is the fact that with the iSCSI gateway, you have a single bottleneck, basically. Here, you have the whole cluster behind you. So the same identical limitations that will apply to a Linux node apply also to a Windows one. So the advantage is that you don't have a single OSD node replying, you have multiple of them. So there is basically no difference at that point in adding Linux nodes for that or Windows ones. So to add on this, also, that is not specific at that point to the solution as a whole, but it's strictly related to the environment that you have.
so while removing the iSCSI layer, are
Yeah.
we seeing any performance improvements?
Yeah, a lot. But it depends, of course, on your environment. If it's a simple test environment, probably not, right? If it's a real production one with a lot of IOPS, you can expect a significant improvement. Even just due to the fact that all the data will not pass through a single gateway, but will be distributed to the whole Ceph cluster behind. Now, again, on our blog, you can find the results from our performance. There are also tools that we publish there in case you want to replicate it in your environment. Maybe you have like a staging environment you want to use for that. That's available as well. Okay. Behind there? Apologies, I didn't hear.
Have you also took benchmark on the
CephFS? No, not yet. That's something we didn't do yet. It's on the to-do list. Any other question?
On the certification side,
Yes.
do you have any specific service or
Services, sorry, on our side?
for Windows certification?
Well, the certification, so the driver will be published again as free and everything. Again, it's something that we want to do as part of the community. So it will be available again for free from our website and everything. What we do as services is provide, as a company, I mean, we provide support, we provide consulting, managed services, and things like this on top, of course, of the open source work that we do. Okay, another couple of minutes we have.
Hello.
Hello.
How many manpower do you have for this project currently?
Well, this is, let's say, an internal reservation for the internal information from the company. Let's say, but we have a support team which is entirely dedicated to this. We have developers which are working upstream, And we have also developers which are working on integrations with other solutions. Okay. Happy to discuss it further, of course. Okay, you're welcome. Okay, thank you very much.